from their local machine and execute it. So with that, I will go with the GitHub repository. I will reiterate, we have shared this link even in one day in advance through email that this is the GitHub repository, aka.ms skaoai, and that is where you will land into the workshop homepage and you can get started with all the modules. For that, you anyway need a Azure subscription. In case you do not have a Azure subscription, you can always use $200 free credit of Microsoft on any of your personal account as well. You would need required permission on your laptop that you are going to access today, where you need to install a lot of .NET toolings, GitHub code spaces, and much more. So we hope that you will have all the necessary and required permission. Finally, we look forward to the champions to complete all the labs, but we are not in rush. Let's understand the concepts here. So if we talk about the lab progression, we have iteratively, we are going to move from a hard-coded response where simply on the agent is returning what you are going to write, right? Like a regular bot will work, it will invoke the intent and it for the greeting, it will have some responses for a particular question. It will have a Q&A kind of a bot, which is generating you the responses. Then we will progressively see how we are getting hard-coded agent responses, right? We will be able to change the agents in the code. Respective agent will get invoked and it will execute those set of actions. Then we will see how we are able to dynamically map these agent responses, and we are able to call those intents based on the prompts that we have. And finally, we will see that there will be a coordinator agent who is going to orchestrate this journey. Means you will have certain things wherein uh, as of in the beginning, the coordinator agent is getting called and then it is passing it to transaction agent, or it is passing it to any other agent based on the context and based on the questions being asked. Right. So we will, in every lab, you will see this progressive journey and we are going to move forward with. Now, to understand the basic concept, right, we have a single agent architecture and we have multi-agent architecture. How are they different? When we are using single agent architecture, basically you are using LLM, and of course LLM is going to use all those kind of tools to do those simple tasks which can perform on a ordinary way, wherein you have set of tools where you are invoking something from internet, where you are doing some data or some transformation on a database and you are generating some kind of responses. It can be anything. But that will not scale for the complex task, right? If you are going to create an enterprise grade kind of application where you want to do certain set of different set of tasks all together, and you really need a supervisor, that is when the multi-agent concept comes in. So in the multi-agent framework, you will have a coordinator or supervisor, which will be able to route it to different LLMs who are executing restricted set of actions that it is supposed to perform. How it helps is it is going to make the overall architecture a lot more performant, because every dedicated agent is going to perform their set of actions. And of course, it can be with respect to different permission, different rights, different departments. You can create a lot of different logical grouping of these respective agent based on your business logic. Let's say in today's example, we are going to discuss banking example where I'm talking about transaction agent and all these things. But in case you are in healthcare, it can be your appointment scheduler agent. It can be your report generator agent, or it can be your doctor consultation, some recommendation kind of agent, or it can be some kind of healthcare offers which are going on with the lab test and all those things, right? Promotional sales offer and all. So based on different industry examples, you will be able to formulate those specific agent and orchestrate that journey through this program of using those LLM, and we will see how we are able to do those complex transformation. Yeah. So coming to the Azure AI Foundry, where you are actually going to action all those things which we just talked about, right? So when we talk about this entire catalog, I know there are so many components and we get lost sometimes in what to use and how to use. So I'm just creating a list of things a short list of things which are available. We call them, some of them are services, some of them are frameworks, some are models, some are tools, right? We are going to use combination of these different components, and we will create our full blown architecture, which we will be using for production. And of course, here you get a list of options, right? In place of semantic kernel, I can use Autogen, right? In case of Azure OpenAI, probably I can use Microsoft Free model, right? So this also gives you the possibility of architecture to design your own tools, correct? So in the current example, as I've highlighted, I'm using semantic kernel for the agent framework. I'm using Azure OpenAI for Foundry models. And then I'm also using Cosmos DB as a backend tool for databases, right? And I will show you how transactional databases are stored in Cosmos DB and what was my reason to use it. As it is much more cost optimal and much more performant from throughput perspective. A lot of benefits that I could see through which I was using Cosmos DB. But of course, you can use Logic App, you can use Azure Function. Of course, MCP is growing, and we can create one more lab to show you how you can also use MCP tools in there, right? And finally, we will see how the story is getting stitched with the Microsoft Fabric. So from Cosmos DB, you will directly see a gateway to put your data rightly on the Microsoft Fabric, where you can perform your analytical queries, your analytical dashboards. So because Microsoft platform is all stitched together, we will see the power, how we are able to transform and route things without writing any logics. It is just a key and a configuration, and we are able to move, right? So the architecture which we just discussed, right? I'm just going to draw some blocks to explain you how it looks like and how we are going to envision how our overall workshop. So in the left side, which you see, right, we have Azure CLI, which I'm going to use for my resource provisioning work. Then I'm using GitHub for my source control and CI/CD. And then I do have a VS Code, which I'm going to use for my Python or C# base code. In the folder of the code, you will see I have both types of code being added. And we can use any one of based on our programming knowledge and our interest. Basically, how we are going to use this front-end app. It is hosted on Azure App Services. It is a basic Angular app with a regular UI. Yes, UI can be reworked and you can work a lot more custom work on UI. We are going to create another version of this lab to show you much more advanced version of UI. But of course, meanwhile, you can also do some custom work on this app side. But main focus and where we are going to focus and show you in this lab is this, the main architecture, or where our middleware sits, right? The semantic kernel, how it is actioning, how it is taking help of this GPT-4o model and creating those contextual responses, right? In this is the focus of this lab, and we are going to show how it is being orchestrated. Of course, in this particular architecture, I'm taking support of Cosmos DB for my vector store. And the benefit of that hierarchical partitioning is like I'm not bounded by the size and the limit. I can scale my architecture seamlessly in the production and interfaces that I'm going to use. Right. So that is the power of Cosmos DB. And I will show you how it looks like in the Cosmos DB, how chat history is being stored, how different data and transactions are being stored in Cosmos DB. So that way it is much more beneficial. And of course, you can use Azure Search in place of Cosmos DB. You can also use a lot many other databases of your choice. You can use a Logic App, which also has nowadays a direct connectors for these OpenAI calls and everything. So that is also different possibility of architecting this app. Along with that, the below component that I'm going to show is about application insight. When you will deploy all the components on your Azure subscription, you will see one more component, which is application insight. So when you will be creating production version of the application and make it live, all the logs and error logs are coming to your app insights. Means you have your production ready app, any errors, that is your first place to go and troubleshoot. Also, you can create some triggers for 400 errors, 500 errors, and things like that. right? So that solves your diagnostic capability. Finally, we also have RBAC policies and secure access management for user permission throughout, which is governed by Azure. So from security perspective, I think we are all good. Now, coming to double click on the semantic kernel pieces, it as we talked about, and we will show as well, there are a lot of different prompts which are being generated, which are being invoked, right? So, how semantic kernel is working on different events being triggered, and how we are talking to Azure OpenAI models to generate the LLM responses, create the parsing, generating the telemetry, and creating all those engine is something will be in the scope to understand. Now, for particularly on this particular workshop, if I have to see that I'm just a user, right? I'm coming to this UI to ask certain questions. So very first thing that you will see on UI is a coordinator agent. Once you will finish all the lab, you will see coordinator agent that is going to transfer whenever I'm asking transaction kind of question. Let's say I want to initiate bank transfer, I want to do some bank balance check, or if I want to ask for certain amount in a certain uh, bank account of mine, right? So all those things will go to transaction agent. In case I have some fraudulent transaction, I want to report, I want to create a case for and all that, I will be navigating to support agent. In case I want to understand any new promotional offer, banking, what kind of interest rates and all those kind of things, then I will be going to sales agent. So this orchestration and invoking the right agent with a common set of agent tool prompts, right? That is what will be taken care by entire semantic kernel interface that we have. So how those agents were working, right? So you say that I have built this example, how in real world you will be able to utilize. So for that, we will be able to use prompts. So how prompts will work is prompts is nothing but a logic, a set of instruction. Like a new hire is coming to your organization, you are giving them certain set of instruction. If this happens, do that. If this happens, do that. Those kind of sequential logic that you are training a person to act and perform certain action in certain situation, that is what prompts are going to do. So similarly, you will be able to enhance your prompts, and I'm going to show how these prompts look like. And as an AI administrator, you will be able to generate and define those prompts very seamlessly. Now, how this routing logic would work. So we have defined prompts, we have created different agents, but now it has to move from one agent to other, right? So all those action, routing logic, how those conditioning is working, how you're taking help from OpenAI to govern these logic, everything is happening behind the scene, and we are able to seamlessly invoke the debug icon will always show you how these routing is being taken, how different prompts and different agents are being invoked. You can troubleshoot and you can make your code much better. So finally, how it looks like when I'm looking at my screen, let's say how my final outcome would look like, right? Once I configure all the labs, I will be able to log into a chat interface like this. So this is the final outcome, but I want to show you because you see a normal chat, in place of a normal chat, I have an agent being invoked. So you see this agent, front desk agent, when I'm asking certain question, front desk agent is being invoked and it is answering me what are senior citizens open and can senior citizen open a savings account? Does the interest rate vary? It is replying to me based on my context, based on my question. It is invoking the right agent. So that's how the final application would look like, right? So if I have to see, and if I have to see how this logic has gone, there is a bug icon when you will hover and you will be able to see these log details. So it will show you how the selection of agent was taken, what was the reason of this selection, how this particular intent was taken taken care of. All these informations you will be able to check. Finally, from conceptual perspective, you understand that of course there will be some agents and there will be some prompts, right? But how they will get the memory, right? Because in agentic world, in with the agents, there will be no memory attached, right? So you will have to do something in your architecture. So here in this example, I'm using Azure Cosmos DB. As I said, you can use other platforms like Azure Search and other things as well. But right now in the Cosmos DB, I'm actually storing that data. Which data? It can be my transaction data. It can be my chat history data. That gives the context to my agent to respond right away. It doesn't have to answer and say all my details again and again. It will be able to pull certain things from my current conversation. So, of course, there is a possibility to make it much better and much more robust on the code, but we are trying to align the concepts, how it works, and how we can make it with the memory associated concepts with the agentic world. Finally, if you have to see that how that memory thing worked, coordinator agent was there. And when I asked him provide my statement for account 001, it has switched to that transaction agent, right? So this routing and switching has happened behind the scene, and it has pulled all my 6 month transaction, and it is able to give me all the responses. Right now, UI is not very good. You can of course work on UI, and it's very easy thing to do, but we are going to show you the middleware part of it in the lab. And our main focus is to show you how this entire fundamental works, right? So I hope this part is clear on this front. And then I'm coming back to these prompts that we just discussed, right? So in the prompts, I told you that we have four kind of agent which we have been discussing. One is the sales agent, one is the support agent, one is transaction agent, and of course a common agent we are keeping, right? So all of these prompts looks like this. It gives a certain set of action. It gives those rule to be governed whenever a certain situation comes. And of course, there is a common agent rule which needs to be followed in association with these specific agent rules, right? So what I'm trying to tell you is you can keep that prompts folder within your code, or you can move it out as a configuration and take help of that prompts folder. So it's totally optional for you. Right now, it is a POC kind of code, and I have smaller set of instruction. That's why I'm keeping it as part of code. But still, I have created four different agent, four different prompty files. Right? You can remove it as a configuration, or you can also create one more transformation on this prompts that you always summarize customers' current conversation and again store in Cosmos DB. And that way, you can create much more better memory, much more extra memory for the agent to respond to the end customer, right? So those are some of the best practices which you can transform even this POC further. Now, how these agent types are configured, let's say you will ask, okay, this is all about banking. How do I make changes in this current code and try to make it, let's say, for healthcare or for other insurance or maybe the other sectors that you are working on, right? It's very easy. You will see in the models folder, there is a agent types. You can change agent type. You can change prompts, respective prompts file, which we just saw. But this is where I've just written four agents. You can create more, or you can rename these agents. You can put your respective logics, and it will be good for you to work on your custom app of your own platform that you are building, right? So finally, when we are looking at these responses, let's say you have changed the code and you are going to run your new logic, right, with the responses. So when you are going to execute lab one, right, in the very first one, it will always respond to you as a very basic and hard-coded response. As you progress and change, it will be able to come to coordinator and move to different agent. But very first response of the lab will come as a hard-coded response. As we saw, I can create multiple different chats from the left panel you see, and then I can even delete those contexts. All these chat history and contexts are being saved in Azure Cosmos DB, and that's the beauty of Cosmos DB, that it is able to all the unstructured and all kind of responses, it is able to store very well and orchestrate between the data. Finally, there are some lab execution common issues which I want to explain before you get started with the actual lab. So one of the issue that we see that when you go to this AZD up, which you do, sorry, in C# infra folder, when you will GitHub and git clone your entire repo, you will be into CD infra folder, and then you will do AZD up. That command is anyway there on module 00. That is the very first where you are going to put all your resources to Azure right? It will ask you which Azure subscription, which region you want to do. Let's say I've chosen Australia East. You can choose your own respective region where you have OpenAI quota. And of course, the Cosmos DB quota as well. So based on that, it will run. For me, it has run in that particular region. But once you do that, right, based on available capacity, it may fail sometime. So what you will do is you will go back, you will do AZD down, delete all the things and try another region, right? In the config file, you may change the region and try with some other region which may work. And that's how you will re-execute. So that's one of the thing. And once it is successful, you will see a green message like this. It has been completed, and you will also see your app link being populated. How provision resources would look like. When you open your Azure subscription, you will see the resource group name that you have given. And BFSI multi-agent was my resource group name. Let's say you can create your own. All of those resources will show inside your Azure subscription like this. So you see so many resources are listed over here. My app service, my application insight object, my container apps, manage identity object, Azure AI Foundry objects. Yes, this is very important because I will go here and I will show you how we can install even 5.0 if needed. And in the configuration, I will just make some changes on 5.0 and it will start working. Then my Azure OpenAI and of course the app service plan. And very important one is the middle one, which is my Azure Cosmos DB object, right? So all of these objects, once you complete that AZD up instruction in module 00, you will be able to see all these provision resource on your resource, right? So finally, that is one of the error. And if everything is successful, you will see all the resources loaded. In case any failure will be there, you will be able to clearly see on the notification bar on deployment wait. So you will again do AZD down and rerun things. So to know the quota, you will have to check with respective regions and retry if needed. And then you will have to sort those quota, OpenAI quota related issue and retry and of course redeploy the resources. One of the final issue that I want to show is sometimes firewall related, which is on the Cosmos DB, right? If you go on settings tab, there is networking tab, and on networking tab, you will have to, sometimes it is disabled by the backend firewall. You will have to click on this selected network and select your IP and whitelist it and then click on save. Update will take few seconds and then you can refresh your app and it will start working. Finally, debugging this code in case some error or something comes, right, on the VS Code, you see this right icon of debug. You can put your breakpoint somewhere. Let's say I have my red breakpoint to get the current date and time where I was just trying to check what date it is taking to pick the last 6-month transaction. So I can put a breakpoint and then I can click on debug button over here and then my entire app will start running on debug mode and I can put some instruction and prompts in the front end and then come back here to see how my backend is retrieving the responses. So uh, I think we are good to move to the code after this setup. So in the code, how you will see the code is, this is how the solution structure would look like. Because you have done the repo cloning and you have opened the multi-agent Copilot solution from Visual Studio to your VS Code locally, you will see 4 parts to it: banking service, chat API, chat infrastructure, and a common folder. So all 4 of them you can clearly see they will be available. And the files that we are basically going to modify are these ones, which I have highlighted here, right? So banking service is totally isolated. It is basically doing all the banking related function. We can even make this API available outside, means make it disjoint from code as well. Chat API is where I'm running most of my code, wherein all those orchestration and semantic kernel related logic is being written. Chat infrastructure is where we have a lot of interfaces code, which we are going to implement in our services classes. So that holds all the library of those function. And the common is something where we have all the helper classes, which are being used at many places, how basic functions are being invoked and all those helper functions. So in the right side, you can see which all are the mostly used files throughout the code. I hope that is helpful. Finally, I'm going to show from my Cosmos DB on the Azure how it looks like. And this is my resource group where I have all of these components. I will open the Azure Cosmos DB and I will show this networking and make sure that is enabled. Yeah, it is right now to all networks, so I'm good. And then I will show Data Explorer. And in the Data Explorer, you see I have account data, which is like this. 001 is my account associated with user ID Nalini, similarly other ones. And then I can show you my chats data. So you see that all of chat history that I've done is being stored here in the Cosmos DB. I have the offer data. So you see different offers and plans. And then finally, I have this user data with all the transaction data, everything. So let's say this is my user data. If you want to make any changes, you can just do those changes, and there is this update button to have that in action. So I will just show one more thing that for the transaction, right? Let's say transaction 001, it was ATM withdrawal transaction. It happened on 10th of September. Probably in your case, you will have to change the date if it is February or old dates. Just make sure that you make it to recent date so that once you hit the queries, you will be able to see the responses. Let's say I have to open some grocery related transactions. So I will make sure the data is all proper. I will change it right here. It is very easy to change and then click on the update button. So that's about it. So basically, when you have executed this whole thing, right, overall, how much is the cost, right? It may come to your mind that how much is the cost. So that is very easy to compute and calculate. Go back to the repo folder. On the main page, you see that I am going to just the main page and home, and that is where about the entire instruction and architecture diagram is shown. Below that, you can see the cost part, the average monthly cost. It is very less. And Azure pricing calculator, based on that, each of these components, tokens and everything, you can calculate and evaluate the cost, how you are going to use this entire framework for yourself. Of course, on the Azure portal also, I can get those cost bifurcations. And further, if I have to go and check the workshop, I will click on this C sharp and then workshop. And here is my home page, right? So from home page, this is where my journey starts to do this today. Module 0 is basically about the setup. Then we will create our first agent. We will connect agents to memory. We will create specialized agent. And finally, we will see how this multi-agent orchestration works, right? So in case any problem happens in your setup, just do AZD down force purge and you will be good. But otherwise, in ideal cases, you should be good to move forward with the AZD up and deploy your resources. So for now, we will get started with 0, 0 and see how it goes. So let's get started with the code walkthrough. So the very first slide that we are seeing is the repo link, aka.ms slash SKAOAI. So I will be simply copying this particular URL in my browser window. And as soon as I land to the home page, you can easily see that in the home page, we are seeing all the module listing and the cleanup instruction. So in case you are going to execute this entire lab, the very first step is about the deployment and the setup. And then we will be continuing as we discussed that first we will be creating a regular agent with the hard-coded value. Then we are going to create the connecting agents where we will specify some memories. We will then create specialized agent and then we will test each and every agent to see if they are working individually when we are navigating to them and putting them on the code and calling the specific agent, right? And finally, we will see that how we can create a coordinator agent and we'll do this multi-agent orchestration through that. So all the labs will go one by one, and this is the home page. In case when you are provisioning this entire lab, if anything goes wrong, there is a command called azd down. Uh, Force and then purge, and this will help you delete all the stuff and recreate the things, right? So before we start, I will just walk through the setup very quick and then we will be able to proceed. So in the setup, we see that we have module 00. Here we have the workshop environment, and as we all know, there has to be a laptop and workstation with the administrator right. There has to be Azure subscription with the owner rights, and we also need some OpenAI quota available for us to do those calling. Though it is not much, but we really need to have some quota available in our subscription, or we will have to request there in which region we do have, right? So these all are about permissions. And in case you do not have required permission or contributors access to your Azure subscription, you can always create a free subscription with $200 of credit and execute this lab, right? Now going to the below step wherein we have this deployment setup and guidelines. So we are starting with the GitHub code space, and I'm sure you will have your own GitHub account because entire source control we are doing through this GitHub, and it will be good if we have the our active account to do those source control and manage our repos and branches that we are going to create. In case you don't have, then also it's fine. You will be able to locally execute your code very well. Now, I'm sure from the installation perspective and even from the setup perspective, you will need a Docker desktop. You will need a VS Code or Visual Studio, whichever it is, with the required developer container extension. So once you have all the setup done, you will be able to clone your repo and navigate to that banking multi-agent workshop and then check out to the start branch, right? This I've just executed and I have my repo ready. So I'll be right away showing from that and then reopening the container because I have my Docker container open and I will be able to reopen my code through that, right? Navigating to these instructions where we have done certain setups on CLI, .NET libraries, and Visual Studio. These all the instructions were sent in email one day in advance for the lab. Please check. You must have the compatible version already installed on your machine, right? So we can proceed with the deployment, but I will just do a quick check before we do those deployment, right? So I will just scroll down to the towards the end and I will quickly see some of the common issues. Let's say some of the issues you might face related to your front end or OpenAI related deployment. You might have missed these things, or you also have certain things where certification you need to do and this trust command you need to run. Sometimes .NET run doesn't work or ES build failed, right? So these all are the common practices which has been specified on this particular page. And I will not spend much time because any developer can fix these errors with the help of GitHub, Copilot, or their own intelligence. But here are the basic one. Let's say ES build is failing. You just make sure you put this npm install this command, let's say, which is a commonly known command, which I'm writing. Let's say I'm on a command prompt. I'll just put this and I'll make sure that I'm on the right installed Angular and all the basic versions are properly installed, right? Also for the ES build, there is this version being specified. So make sure you install respective versions. And in case you are facing any issues, you can always do clean force and you can do reinstall and check your ES build version with the command npm list ES build. That will show you the current version. Yeah. So let's say this is going on, but let's get started with our lab while this is going on. And to start this entire thing, right, I will just go on the top and see deployment instructions, right? So for the deployment, we always go to CD, C sharp, and the infra folder. So there'll be two parts, right? One is the backend and one is frontend, right? So I'm opening this entire code. Let's say I will do a git checkout branch and I will be on my start branch. Now I'm opening in the Visual Studio Code. And as I open the Visual Studio Code, I will quickly show that I have my repo already being cloned. Here it is. And all of these files are being loaded from that branch. Now, if I have to see AZ auth login and AZD up, once I do that in my infra folder, I will be able to deploy all the resources to my Azure folder, Azure subscription, right? So see, I've done that in before the lab, so which I can show you. Here is my Azure subscription where I have my resource group with the name, BFSI multi-agent, and all of these resources has been deployed. So once you will be starting your deployment, you will quickly see that the resource name that you are specifying in your setting file, all the resource will start getting created in the backend one by one. So with the command AZD up, it will take care of creating everything, right? And it will even ask you, do you want to put some testing data as well? You will say yes, and it will load the testing data as well. So you will see these true, true, true when you see deployed for the first time, and entire test data will also be installed. Now, when we are working on this workshop, there is certain environment variables which you need to verify. So I'll go there and verify those environment variables. On my folder, which is here, uh, dot Azure, and then I have my BFSI multi-agent. This is my resource group name. Inside that, there is dot env file. This is the file where you will see all of your environment variable being created, right? So everything from configuration, you will be copying into your the other file, app settings.json file. So those all the instructions are written in the activity 4, where one by one you will be copying everything to app settings.json. So see, we are over here, we open the .env file and then we go to chat API and we see the app settings.json file, right? So I will go to chat API. Here is the chat API and app settings.json is right here below this. And then you keep on seeing on this particular file, right? There are three placeholder. One is for Cosmos DB settings, where you will be putting this Cosmos URL, which we are going to pick from a .azure file from my resource group. This is what I've deployed on Azure. So that is the URL being created. Then my semantic kernel URL. And then the final one is for the OpenAI, the entire URL is what you are going to copy and put it here in the connection string, right? So that's what is mentioned in step number 7. Once we complete that, right, you are good to compile and run the application. So we will see how it looks like. And before that, you can quickly do this trust and then run, right? Trust means you are just certificate related work that you are doing. So I'll show this step. Let's say I'm over here. So this is my banking folder. I have done CD C sharp, CD SRC, and then CD chat API. So once I do that, now what I can do is I will just quickly do .NET run. So this way you see in my terminal, I have successfully executed the backend app. Now it is the place for frontend. So I will create another terminal and let's say I will cancel this and show you I'm on the front end folder. What I'm doing is ng-serve, but when you're doing for the first time, right, then the instruction would be to do npm install and npm start, right? Because I have already executed this, I will be doing ng-serve and then I'll be starting my front end. It will provide me a localhost URL. Once I click on this particular URL, It is opening in a browser. And here is my front-end application. So I'm selecting my username and the app name. And I click on login and it is opening the conversation. So yeah, here is my session. Let's say I'm just doing a follow. In your case, when you haven't implemented anything, the very first response that you will get from lab one is a basic hard-coded step, and then you will proceed and transform your lab to the step where you are able to see the final multi-agent response, right? Which is like this, where agent and coordinator is responding you with everything, and the bug icon is giving me all the transaction it has done, all the routing it has performed to reach and respond to me, right? So you will reach to this step once you finish all the labs, but yeah, you will see some responses even at this stage when you are at the lab zero, right? Now, I want to quickly show you one more thing when we go to lab, right? In the NPM build, you see that if there will be any error, right, you will be able to see it here. And I have to show you one of my previous error just for your reference purposes, that even after initiating the chat, if it was failing, right, I will see a fail message and it will tell me what are the error. Let's say it was a 403 error forbidden, right? That was the issue with the security. So Cosmos DB was not allowed for that IP that I was using. So I had to enable that, and that's how I've rectified the error. Right. So this is quick debugging step that you will see on the backend where it will fail at some step and you will be able to come and debug over here. Going back to our lab step, where we have completed this and we have started the lab, and you are able to see this replay user message, hello, how are you, right? So this is your final outcome of module 0, which you will be able to see. And always you can do Control C to stop the application. And from ID, if you are running Shift F5, you can press and run the application, right? Now moving to the module 1, when you are creating your first agent, right? So a single agent architecture, we are creating our single agent, and then we are trying to see how we are able to calling the chat and how those plugins are created in the backend, right? So you see that this architecture looks like this, that you have a main as a chat API and a chat infrastructure where you have a lot of your helper classes and everything. You have a common folder where you have some common library files being written, but all your main transactional work that you are doing is within Chat API, right? So we will be talking about various folders over here. Let's say there is a class called Semantic Kernel service, which we are going to implement. So we go to the chat infrastructure where we have most of our interfaces available. In your IDE, navigate to chat infrastructure project in the solution. So that's what we are doing. In the IDE, chat infrastructure, and then what it says, create a new class, iSemantic kernel service.cs. Create a new class, interfaces, iSemantic kernel.services. I've created this. You will just go here, right click, new file, and give that name. It will be created, and then entire content of that file is being written over here, which you will be copying. Then you will be creating a semantic kernel. From that, you will create a class. You will implement from that interface. You will implement a class again, which is in the services folder. So in chat infrastructure, in the services folder, here is the services folder. And here is what I have, my semantic kernel service.cs file. And then I will be copying this entire code over here. Finally, what we will be able to do is we will be creating a simple agent, means within get response function of semantic kernel.cs, we are going to change this code from the try cache block. So this entire code, whenever you are going inside the code, right, it will actually tell you where you should be copying it, right? So get response, you will be copying this entire code over there, right? So let me show you quickly here. So here you have copied that code, which I was showing. A next step to the lab is add dependency injection. So again, in the chat infrastructure, in the services folder, you will be opening dependency injection.cs file. Here is that. And then you are going to copy this particular code, which is add semantic kernel service, which I have already copied. So you can see that this code is added at the bottom, which is right here. Now we are integrating. So this particular instruction, you will be able to create chat infrastructure slash services folder. So inside that, there is a folder called chatservice.cs. So here is the one. And then at the top, you will be adding those references on the top. And then on the chat service constructor, you will be able to add these new lines, which is written over here. Now you are going to change the chat service.cs, go to this particular function and update the code for get chat complete async. This entire code will be copied in that class. I will quickly show from there. Here is the code, and you can clearly copy and see how we are going to change this code. Finally, in the next function, summarize chat async. Here it is. So this entire code is being copied. And then finally, in the final step, initialize semantic kernel.cs on the top, right? Add Cosmos DB services and this code, which I will just show. Program.cs, right? So I'll just go to the program.cs. And here are both the functions that we were just talking about. Builder.add Cosmos DBs and this one. Right. So this is done. Finally, you can test your work. So similarly, you will just have to, your front end is already running. What you can do is you can just go to backend and do the .NET run again. And that's how you will be re-executing your code, right? So I can just do one thing, means Control C. I close this terminal and then I do .NET run again. Front end will run same. We do not have to do any change. So ng sir, you do not need to run again, right? So here we complete the module one and the response would look like this. So you can see that a singleton response is being coming, just a program, but I'm here ready to assist you. How can I help you? You will receive this particular outcome after your lab one, right? Any issue or any error that you will find, right? So there is a hack to it, right? Finally, what you can do is, in case any of your file you think you have missed or you haven't done something properly or same, what you can do is you come here and all these file you can copy paste from here. Exactly. So it is kind of a cheat sheet, which is at the end of every module, all the files that were changed during that particular module has been written, and you can manually copy each and everything from here. Right. In the next step, we are going to connect our agents to memory. Like we talked, right? Agent doesn't have memory. How we can create a database or some kind of context to the chat so they know how they should be responding contextually, right? So that is our next lab two. Here is the lab two. And here we are going to create the session memory, which we are going to talk about, and how we create those memory persistence for the agent framework, right? So in the very first step, you have created those session memory persistence in the agent framework. In the step two, you are creating a simple banking agent. So now in this entire module, right, we are talking about one of the banking use cases where everything related to banking, right, we have created on a separate folder. If you see, you can create a separate API that can be an independent API as well. I'll just walk you through how the code look like. You can see that, right? We are here in this structure, C sharp. Under that, there is this infra and then SRC folder. You have four folders. One is banking API, which is totally about all the banking related functions. Chat API is our core fundamental where we are talking about all those agentic framework and everything. Chat infrastructure is creating our interfaces and our code definitions. Common library we using for our helper functions and some of the basic functions that we want to call and execute about, right? So as you see, banking is one of the API which is totally discrete from this project. There could be healthcare API, there could be different finance related other module that you want to execute. You can create in the similar way, or you can even isolate it from entire project from here. So those are the architectural guidance that can help you build your own project for your respective purposes. Now coming to the particular lab, module 2. In the module 2, basically what we are going to do is in the factories folder, right? You will be creating a system from factory.cs. So I'll just show you from the factories folder. In the chat infrastructure, you will have factories, and here we have so system prompt factories, system prompt factories, and here is the entire code that needs to be written. Then you will go to factories and then create chatfactory.cs. Here is the chatfactory.cs and the code can be copied. After this, you will be moving to chat infrastructure, then services, and then semantic kernel.services. Again, semantic kernel.services is your main function where you will keep making changes to call your agentic framework differently, right? So I'm just going back to my services folder. And here is my semantic kernel services. And then at the top, I'll be adding this particular line and update get response function. Get response function is the key function where we have been changing the logic. So you see that there is a message history and this entire code from the get response is being copied over there. Now, finally, we are going to store user messages and responses in Cosmos DB. So for that, we are again going to the interfaces folder in the chat infrastructure projects, and we will go to iCosmos DB interface. Interfaces. Here is the iCosmos DB. And then we are going to copy paste this entire code over there. Finally, Cosmos DB services need to be updated. Interface is just updated. Now we are going to services. So in services, again, Cosmos DB services. Here is the file. So in the Cosmos DB services, this entire file needs to be copied. Now we are updating the chat service. So under again services, chat service. So basically here you can see that this entire, this can be copied. Correct. Finally, we also need to change the within in the beginning of the same chat services, we need to locate this function. Here it is. And then we have to update this try block with this particular code, which is right here. Here it is. And then we will finally test our module 2 as well, which is completed with all the file copies, right? So once you complete this, right, you can see that because we have created some persistence, right? Now agent knows, he understands the context, right? So let's say we have asked, can a senior citizen open a saving account? It is responding yes, and it is responding with the number of um, different options that they have, right? Now, front desk agent is being called. You can clearly see front desk agent is being called in this particular responses. Now it is asking, does the interest rate vary? So it is also telling based on the intelligence it is responding. So now it is contextual. It is responding with the context that it has to answer. So again, even after module 2, you will rerun your .NET run, means you will run your backend again. And then from front end, you will keep it same and re-execute and see with some of the things like does interest rate vary. And I have to show you this, that whenever something is executing on my front end, it will show me all the logs, that what is the current logged in user, what are the traces being going on in the backend for the responses to be generated. And you see my responses are here. And I understand you have question, and it is responding for, there is a time where I'm supposed to ask these things, tele banking and all. Based on its intelligence, it has redirected to a different agent and it has tried to respond me to my query. Going back to the agent, where I have to execute the next one. Right now for you, you will see the hard-coded one. I am getting the final outcome. That's why you are seeing a coordinator being rerouted, but you will see the hard-coded front desk agent. And in the code, you can change it to different agent and make it run. Now, going to the module 3. In the module 3, from the beginning, here we are talking about agent specialization, right? So in the last module that we saw, that we have created this persistence in the memory, that we were able to talk to a particular thing on based on the context, it was able to answer. Now we are going with agent specialization, means if I'm asking transaction related question, it should go to transaction agent. If I'm asking a certain, we will be dividing certain functions for the agents. Agent will be executing those list of tasks which it is designated to execute. Of course, every agent will be working as a common agent. It will follow the prompts as a common agent it is supposed to follow, but it will do its specialized work as well, right? So that's how it works, right? Like that we will see how prompts work and how prompts are getting merged with a common prompt of a common agent guideline. Okay. So here is the thing. Let's say I'm doing for the bank domain data model. So you can see that for the banking module, right, it has all the model data being created. So this modeling page, right, it gives you the definition of your schema based on the use cases that you are building. Let's say this is for banking. That's why I'm seeing bank transaction, bank account type, bank service requests and all, bank offers and all. But if it is a healthcare organization, it can be like those booking data, patient data, record data, appointment, test, and all those history, schedule, their prescription, and all those things. So based on different use cases, you are going to put these models on, and those helper classes will help you navigate through these codes that we are going to write. So here we are defining the agent behavior. I'm going to the very first class where I'm going to write those prompts. Prompts are nothing but the intelligence that we are going to provide to those model, right? So we will see these from folder from chat API. Here is my prompt folder, and this is basically the intelligence that we are giving to our agentic model that we have. Right now, I have just written this minimum intelligence, which is a common agent rule, and then my coordinator rule and my customer support agent rule. Then I have my sales transaction related prompts. to understand how it will understand the promotions and offers. Then I also have selection strategy. I also have termination strategy. So all of these prompts are basically defining a rule, a specialized agent. Let's say a customer support agent is a specialized one. It is always combining a common agent rule, and then it is doing his own specialized prompts, and then it is generating the output. So this prompt file is the intelligence that we are giving those guiding principle. It can be out of your code. You can detach it out from your code. It can be a configuration file as well, and you can remodify and readjust based on. It can be a huge file. There are also again different kind of architectural concepts that you can do to define these prompts file. Sometimes it can be very lengthy and everything, and sometimes your efficiency of your models are affected due to these prompts and all. So there are ways to create some kind of memory, some kind of summarization of the context with the help of these prompts, and optimize those things as well. So you can always play around with these prompts, keep it outside the code. Because of our example purpose in this code, in the POC, I'm just putting it inside the code in one of the folder, which is prompts. So in the prompts, you see that I have this common agent rule. It will you will see in my basic class whenever it is getting called, always a common agent rule is called even with these specialized agents. Now, let's say we have talked about all of these prompts. We are going to create some of the classes here in the chat infrastructure in the factory, system prompts factory, and you see that I'm getting the agent name, I'm getting the prompts out of it. So it is running this code based on the different inputs. It will invoke the respective agent, and it will invoke the respective prompt actions, right? So here is the code for this where the switch case works. So okay, this entire code is being copied in the system prompt factory.cs in the factories folder. Here it is. Hope this code is copied. Now we are moving to the how those agent plugin folder is invoked, and then base plugin.cs is being called, right? In the chat infrastructure, we will open base plugin. Here is the agent plugins, and here is the base plugin. This is the main class, and I've also put some breakpoints, right, when I was doing the debugging of this to find out some of the time and all those things. So let's say if you're calling anything, I want to know my last 6 months transaction. So that is where the base class will be called. It will take the current time and decode and check the user ID and everything, and then pass it to respective agents and everything to call and do the operations, right? So this is a very important class. If you face some kind of challenges, this is probably a place where you will put a breakpoint and see through. So let's say you have this agent base plugin, you will put this code, and then in the sales plugin.cs, right, which is here. So here you are writing the logic for the how different sales offers are navigated. So this entire code will define that. And finally, customer support plugin.cs, you will put customer support.plugin. This entire code is being written over here. After this, the transaction plugin. So each and every agent and their specific role you are specifying through this module 3, which is very interesting. And then you will see how you create develop a plugin factory, which is plugin factory.cs, and you are calling these agents, respective agents in the kernel clone. So here each of them are being called based on the definition being called. And finally, you are building an agent factory, right? So you are going to the factories and then open chatfactory.cs. Here it is. And inside that, you will replace build agent functions code with this particular one. So this is a very important code where you will see that how they are being called, different agent types, and you can even manually change them and see how it is functioning. Finally, you are creating data model for the vector search. For that, there is offer term in the common folder, models and the banking. And here is the offer term. So this is the file where you will be making the changes and then update the banking services in the interfaces, I bank data services. So again, in the interfaces, chat infrastructure, interfaces, I bank data services, and then you are going to update this particular code over there. And then finally, in the services, banking data services, the services folder, and that folder is here. Banking data services and interfaces right here. So this is one of the change that you need to do for the banking related function. All the interfaces are here in the banking API, and the implementation is here in the services folder. Fine. Finally, this is implemented, and then agent plugin. And in the sales plugin, you will just add these two, which is pretty straightforward. Agent plugin folder, chat infrastructure, and here is the sales plugin, and then you are changing this particular code. That's it. So that's it about the module 3, and you will put some of the changes in the get response function for isemantic kernel dot services. You'll add these lines, and then again finally we always have to make changes in the semantic kernel dot services, right? So you will be changing the get response method, and this time it is going to call respective agents. Let's say I am calling this customer support agent. You see that, building the agent, and I'm calling customer support agent. So it will respond to me with this if I have the existing case, if I'm playing around with what are my cases, or which account I'm talking about. Do I want to add any comment to my existing case? All of that will happen, right? So finally, when I'm calling this in the chat service, I will make these changes. I'm going to the services folder and then chat service, right? So that's about this entire lab. And then finally, we can test our work with each agent type. So this is pretty interesting, which I just told you, right? So customer support agent, you saw that above code. Here, I can change agent type dot sales agent. I can make it transaction agent, agent type dot, and all the options will come for me. And that way I can test each of my specialized agent. Correct. So it is also giving you the examples how the prompt should look like based on different particular agent that I have. Let's say how much did I spend on groceries? So that is basically for transaction agent, or looking for a high interest saving account, right? So that is for my sales agent. And then file a theft for my complaint for my account 001. So 001 is tagged for me, right? So I will be able to invoke the customer support agent through that, right? Finally, I will test again. So you do not have to run the front end. You can just run .NET run in your backend app. I'll quickly show again how it looks like. So you see my backend, SRC chat API, just control C and then .NET run again. ES build, this tab, which is another terminal where I'm running my front end with the npm build earlier and then ng serve when we are running the front end every time. So this you can just keep it as it. Just go to the different tab and run the .NET run again to execute this lab 03, right? Finally, lab 04, which is our final lab. So far, we are executing each agent's response, right? And semantic search is also working fine. Now we will go how we have a coordinator agent routing through different various specialized agent, and then how we are able to orchestrate this entire journey. That is our multi-agent orchestration. That is our final lab, the lab 4. So in this one session on multi-agent architectures, right, you will learn and then define agents and their roles, both of these activity, what we are going to do. Then we will have a coordinator agent, which will call a specialized agent whenever needed, right? So selection strategy we will define based on which agent will be invoked. So how prompts will run, and there is a lot of testing required for these prompts, and a lot of even a comma, a slight error can create a different responses, and also it is you will learn when you create projects on your own, and you will be running through your journey. So finally, termination strategy for the agent response will also be written. How do you terminate? What are the rules set and everything? And then chat response format, how it would be. Right now, UI is not that great that it is responding you a very linear statement. But in the coming version, which we have, the new agentic framework and everything that we are talking about, UI is going to be really nice, and you will see a lot more changes and updates through that. So in the chat formats, you will create those terminal formats .info, chat info formats, and then in the chat infrastructure, you will again create those chat response format .cs file. So I'll quickly go to chat infrastructure, and I have my structured formats where I have defined these chat response formats, which we just talked about. And then we have just written those structures. All those will be defined. And then finally, there is a chat infrastructure factories file. Here is my factories file. And then inside that system prompt factory, here it is. And this will define my different prompt invocation logic. So you can copy this entire line from here, which is building, and then strategy prompts. Then system prompt factory, there will be a get agent prompts. Here it is. And then you will be adding a new function at the bottom of the class, which is here. This is added. Finally, factories chat factory.cs. Here is the file. And then you will add references and then build agent function. At the end of build agent function, you will be adding this code of OpenAI prompt execution, this entire code. And then finally, you will create the semantic kernel.cs. That is the final change. Always you are changing this file, right? So in services, semantic kernel.cs. We are moving to semantic kernel.cs file, and then get response. This entire code needs to be copied and need to be replaced. That's it. After that, you will be able to test. And this time, your coordinator is invoking different agents, right? So when you are asking several questions, right? So if you are asking transaction related question, it is invoking the transaction agent. Let's say I was showing it, right? Initially, my coordinator was there, and then it has invoked the customer support. If I'm asking my last 6 month transactions. So this is the final one where it will go and navigate through and check which agent needs to be called. So when it is performing this, right, you see in my build, I will keep on getting all of these logs, how it is going, filtering, and it is checking the start date, and it is checking the data. You see 4th April 2025 onwards, it is fetching the data. You see? It went in the backend, and here it has received all my transaction of those date. You see, 10th of September 2025, I've made some withdrawal. I know the output is not that formatted, and UI is something being worked out in the later versions that we are working. But see, this is how it has all fetched my respective transaction, and it has routed it to transaction agent. So important part for you to see is I was on the coordinator agent. It went to customer support, but it has rerouted me to a transaction agent. And here's the bug icon, which will tell you how and what were the reasons of different prompts for me to get to the right agent when I was needed, right? So that is what it is about the agentic framework, that we are calling the right agent, respective agent, and it has those intelligence, it has those memory in memory through which it is able to define. And Cosmos DB is helping you with those storage, because it has to store all those contexts, all those chat history somewhere where we needed a most optimized approach to store it. It can be a Azure search as well. It can be a different place as well. Based on your own use cases, you can define the architecture. So that's about it. That's the final exercise to test the work. And that's about all the exercises.